Hi there, in this video we'll be learning how to find out the probability by using a sample space diagram. So here you see that we have got a sample space drawn already for us. I'll be reading a question and I'll be highlighting the main key information. So let's have a go on it now. So this says that Jake rolls a fair six-sided dice. So it's a six-sided dice is the first piece of the information we have been given, and spins a fair four-sided spinner. Another thing is the spinner, which is four-sided, and adds the result together. So to fill that in table, we're going to add both the results together. Now here we have got the sample space given, and part A says that copy and complete the sample space diagram to show the possible outcomes. So what is the sample space is basically, it shows you all the possible outcomes of the given situation. So in this given situation, we are having the dice with the number 1 to 6 horizontally. Vertically, we have a spinner, and the number on that would be from 1 to 4. The relation between them is to add them together. So to fill in the table, each number is going to be added together. So I'm going to fill in the table now. 1 plus 3 would be a 4 here. 1 plus 4 would be 5. 1 plus 5 would be 6. And 1 plus 6 would be 7. To fill in the next row now, we do the same thing, which is 2 plus 2 is 4. Then 2 plus 3 is a 5. 2 plus 4 is a 6. 2 plus 5 is a 7. And 2 plus 6 is 8. Let's fill in the third column now, third row. Let's fill in the third row now. So 3 plus 1 would be a 4. 3 plus 2 is 5. 3 plus 3 is a 6. Then 3 plus 4 is 7, 8, 9. To fill in the last row now, that would be 5, 6, 7, 8, 9, and 10. So we have got all the possible outcomes now when we roll the dice and a spinner together. If you read the first part now, the first part is about to find out the probability of getting a total of 4. I'm going to find out how many are the total outcomes, and then I'm going to use how many of them are giving a total of 4. So the total outcomes would be, we are having 6 possible outcomes horizontally and 4 vertically. So when you do 6 times 4, so the total outcomes would be 24. Okay, because we are finding out the probability, and probability can be expressed in one of the form, which is a fraction. So we're going to see that this is that we are finding out the total of 4. I'm going to highlight all the ones which are giving us a total of 4. So this is giving the total of 4. Then we're having this, a total of 4, and this is another 4 we're having in the list of the outcomes. So we see that now, how many are the 4 outcomes we are getting? We are getting 3 of them, so I'll be writing I here. So to find out the probability of the total 4, what we see that how many are the number 4s we are having in the sample space? So we're having 3 of them out of 24. Whenever we are finding out the probability, the denominator always goes in the, whenever we are finding out the probability of anything, the denominator is always the total outcomes, and the numerator is what we are looking for. So now we see that we are having 3 and 24. We try to simplify them and we divide both of them by 3. So how many 3 makes 3 would be a 1, and how many 3 makes 24 would be 8. So here's the probability of getting a number 4 from this sample space. Let's have a go on the next one now. This is that a total that is a square number. So we know that what are the square numbers. So the first few square numbers are basically, I'm going to write it down over here. So the square numbers are 1, 4, 9, 16, 25, and we have got more square numbers as well. So now we're going to see that what are the square numbers, and we're going to try to circle or highlight the square numbers. So here I'll be highlighting all the square numbers now. So because 4 is a square number, which would be here. This is another 4. This is another 4. The next we see in the list is 9 is a square number. We have got 9 here, and we are having another 9 here. So now we're going to see that how many other square numbers we are having. So this is the part II. We are finding the probability of the square numbers. So we count how many other square numbers. So that's 1, 2, 3, 4, 5. Altogether we are having 5 square numbers, and in the denominator we always write down the total possible outcomes. So here it's 24. That would be the denominator. Because now we are having 5 and 24, they cannot go in any same times table. So this is already the simplified answer. Let's have a look to the next example, next part now. So in the next part, this says that find out the total of 12. Now I'm going to highlight all the ones which is giving us a total of 12. So this is a total of 12 we'll be looking for. So we'll see that in the list of the numbers, do we have any 12 in here? No. The maximum we are getting a number which is 10. So to find out the probability now, so this is the part I. Here we are finding out the probability of the total 12. Because we are having no number which is giving us a total of 12, so we write down 0 over 24. And we know that any number that divides or multiplies by 0 would be 0. So here we get the probability of getting total 12 would be just 0. So now let's have a look to the next example now. Here we have got the next example. So with the next example, this says that 3 cards are numbered 1, 2 and 4. 3 discs are numbered 2, 4 and 5. So we have got 3 cards and 3 numbers. A game consists of playing 1 card at a random and 1 disc at random. The numbers on the card are subtracted from the numbers on the disc. So what is the relation between them is the subtracted this time now. So I'm going to highlight this key information here, which is subtracted. And now I'm going to write it down over here. So between them, between the disc and the card, the relation between them is to subtract them together. So here the first one is done for you already. So the first part is to complete the sample space, and to fill in the all possible outcomes, the first one is done for you already. So you do 21, take away 1 would be 20. The other one would be 4 minus 1 would be 3. 5 take away 1 would be 4. Here's the first row done. We're going to go on to the next one now. So 21 minus 3 would be 18. Then 4 take away 3 is 1 and 5 take away 3 would be 2. 21 take away 4 would be 17 here. 4 take away 4 is a 0 and 5 take away 4 would be just 1. Okay, so here we have got all the possible outcomes. Now let's read the next part, and that's for 2 marks. Now the next part says that what is the probability of getting a total which is an even number? So here I'm going to write down what are the even numbers. So to do the even numbers, here's the list of some even numbers, which is 2, 4, 6, 8, 10, and there are more. We're going to see that we're going to highlight the even numbers now. So 20 is the even number. So even numbers are those numbers which are actually the multiples of 2. So we are having 20, the even number. Then we are having 4, which is a multiple of 2. So it is an even number. 18 is an even number. Then we have got this 2 is an even number. So here we have got 4 even numbers. So because they ask us to find out the probability, so to find out the probability of the even numbers, that's even numbers, we know that the numerator is always what we are looking for. So we see that in the list of all the numbers, we have got 4 even numbers. So we write down 4 in the numerator. Now think what I said in the previous example is that whenever we are finding out the probability, what's the denominator is the number of all the possible outcomes. So you have got 3 outcomes in the horizontal form, 3 outcomes in the vertical. So you do write down total outcomes here. And rather you count them together, you just do 3 times 3 would be a 9. So here you have got the possible outcomes are 9. And the total number of outcomes, as I said, to find the probability, the total number of outcomes would go in the denominator. So the probability of getting the even numbers would be 4 over 9. Now here's the part B now. So in a different game, the probability of getting an even number is 3/5. What is the probability of getting a total which is an odd number? So now we see that we know that what is the probability of getting the even number in some other game, which is 3/5. This is that what is the probability of getting the odd number would be. Now we are finding out the odd number. Because it's the probability of the even number is given in a fraction form and is 3/5, so the probability of the odd number would be the remaining fraction. So the probability of getting the odd number would be 2/5. Now we're going to have a look to the next example now. So in the next example, we see that we have got 2 spinners, and this says that he spun both spinners. His score on the 2 spinners is multiplied together. So now the key information over here is the relation between the 2 spinners is a multiplication, and here they have written it down. Now this is that complete the table to show all the possible outcomes. We'll be multiplying the numbers. So no matters, either you do the spinner 1 number multiplied by the spinner 2 or spinner 2 by spinner 1, multiplication gives always the same answer. So let's fill in the sample space now. So 1 times 0 is a 0. Then 1 times 2 is 2. 1 times 3 would be 3. To fill in the next row, we're going to multiply again them together. So 3 times 0 would be 0. 3 times 2 is 6. 3 times 3 is a 9. To do the other one now, so to do the third row, 5 times 0 is 0. 5 times 2 is a 10 and 5 times 3 is a 15. Here we have got the sample space. Now before we do the next part, we can write down how many are the total outcomes. So I'm going to write down the total outcomes would be 3, 6 and 9. So we have got the total outcomes would be 9. Now we're going to read the next part now. This says that Phil says that the probability of getting an even score is a half. I'm going to highlight this information. So even score is a half. Explain why Phil is incorrect. So we're going to find out the probability of the even score and see that why Phil is incorrect. So probability of the even score is, we see that what are the even numbers. Let's highlight the even numbers. So it's 1, 2 and 3. So we are having 3 even numbers. Let's write it down in a probability form, which is the fraction. So 3 over 9. When you simplify this 3 over 9, it would get 1/3. And of course, because 1/3 is less than a half, 1/3 is a less than half, therefore, you write it down that Phil is incorrect. So we never, for these sort of questions, just like what commonly the student says that without any kind of the justification, the student says that Phil is correct because of this. But I always recommend that show the working out and then show it through your working out and then write down the final conclusion where you say that why you think Phil is incorrect. Now here we have got the next question now. And again, I'm just using the highlighter to highlight the key information. This says that Harry flips a fair coin. So now we are talking about the coin which he's rolling how many times? 3 times. Work out the probability that the coin lands heads up for all 3 flips. So I'm going to draw a sample space for the coin if they're the 2 coins. So I'm going to first do for the 2 coins and then I'm going to do for the 3 coins. But once you would have a practice, you can do straight for 3 coins as well. So I'm going to show you in 2 different ways. So the first thing, I'm going to make a sample space when you're having 2 coins. And I'm going to write it down over here, 2 coins. The possible outcomes on the coins is a head, tail and the head, tail. So let's fill in the sample space. The first would be head and head. The next you're having is a head and tail. Then you're having is tail and head and then tail and tail. So this is the sample space for the 2 coins. But because we are having 3 coins, so I'm going to make another sample space. Here I say that I've got 2 coins and here is the 1 coin. So now is 3 coins. Now the possible outcomes of the 2 coins are head, head. Then we have got head, tail. Then is a tail, head and a tail, tail. And on the 1 coin, the possible outcomes are head and tail only. Now we're going to fill in this sample space. So the first one is, this is a head basically. So the first one would be head, head, head. The other one would be head, head and tail. Then it would be head, tail and head. Then it would be head, tail, tail. Let's do the second row now. So I'll be writing tail first and then 2 heads. So tail, head, head. Then tail, head, tail. Then we are having a tail, tail, head. And the last is a tail, tail, tail. So this is a sample space for all the 3 coins. This is one of the way of doing it. Another way of doing that is just you don't have to draw the table. You just write them down. So head, head, head. Then you keep on changing the head with one of the tails. So head, head, tail. First when the tail was at the end, now the tail will go in the middle. Then the tail would be at the start. Once you have taken all the combinations, when the tail is only appearing once and the head is twice, then you write down more combinations when the tail is twice and the head is 1. So you write down tail, tail, head. Then you write down tail, head, tail, head, tail, tail. You have written down all the combinations when the tail is twice and the head is 1. The final one is when you get the tail 3 times. So either way, you would have the same sample space if you draw it through the table or you just list them. Now, here this says that, I'm going back to the question now. Harry flips a fair coin 3 times. So we have got the sample space for the 3 times. Now, the original question is, what we are finding out is the probability that the coin lands heads up for all 3 times. So we are finding out the probability when it appears the head in all 3 times. Because we are finding out the probability, the numerator is the favorable outcome. So what the favorable outcome means is we are looking for all 3 heads. So all 3 heads is this one, which is only appearing once. So I'm going to write down 1 on the top. and the denominator is the total outcome. So we're going to see that how many are the total outcomes we are having in this sample space. So this would be 4 in the 4 in the top row, 4 in the second row, so that would be 8 altogether. So 1/8 is the probability when Harry will get 3 heads. Now we have got the next example, and what I have taken in this video is majority of the questions are from the book, from the higher book, and it really builds up your understanding that how to understand the topic, this sample space, and how to find out the probability then after finding the sample space diagram. So have a go on this example now. This says that Chloe has 2 bags of sweet A and B. So here's my highlighter now. So there are 2 bags with A and B. In bag A, the flavors are the strawberry, orange, lime, and blackcurrant. So what I'm going to do is I'm going to draw the bag A. So you can draw this bag, and this is a bag A. I'm going to label it as A, and there's another bag now, which is a bag B. So I'm going to write down what are the flavors we are having in a bag A. So it's a strawberry flavor, which I'm taking as S. Then there's an orange flavor, which is a O. Lime is with L, and blackcurrant is with B. So we have got 4 flavors, 4 different flavors in a bag A. Let's read the next piece of the information. In the bag B, there's a strawberry, blackcurrant, and a lime flavor. So I'm going to have 3 flavors in the bag B. So strawberry, the next is a blackcurrant, and the third one is the lime flavor. Now this says that draw the sample space to show the possible outcomes. I'm going to draw the sample space over here now. So the sample space is basically making a table. I'm going to write down this is my bag A and this is the bag B. The possible outcomes of the bag A is S. Then S is for the strawberry, O is the orange, L is the lime, and B is the blackcurrant. What flavors you have in a bag B, you're going to write it down over here, which is strawberry, blackcurrant, and lime. Now you're going to write down all the possible outcomes of them, because this says that draw the sample space. The first one would be when you're going to write down S and S. The other one would be S and O, then S with L, and then S with B. I'm taking the initials of the flavor. I'm not writing down the strawberry, the whole thing, blackcurrant, the whole thing. And you can take even the same thing in the exam or while making the notes as well. So you don't have to write down the whole thing. Just taking the initials is enough. So that would be B with S. Then the next is BO, then BL, and then BB. To do with the third row now, you're going to do with the lime and the strawberry. Then lime with the orange, the lime with lime, and then lime with the blackcurrant. So here we have got the sample space with all the possible outcomes. So we are done with our part A. Now this says that part B is work out the probability that the sweet will be both strawberry flavor. So because this is a question to do with the probability, so I'm going to find out is the total outcomes. So how many are the total outcomes would be? You see that what are the outcomes you're having in the horizontal. In the bag A is 4. In the bag B is 3. So you can multiply them together. 4 times 3 would be 12. So it means that the total outcomes you'll get is 12. If you don't want to multiply, but you can also count them as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So either way you would have 12 then. Now let's have a go on the part B, I. And this says that find out the probability. What we are finding out the probability that both of them are the strawberry flavor. So I'm going to write down over here, we are looking for both strawberry. So I'm going to write down both S. So how many other outcomes that give us both strawberry is? This is the only which is giving us strawberry and strawberry. So this would be then 1 out of the total outcomes, which is 12. Let's have a go to the next one now. So this is a II, and this says that the same flavors. So the same flavors could be, either it could be strawberry, strawberry, or I can see that what are the same flavor is B and B. The other same flavors I can see in my sample space is a L and L. We can't have orange and orange because we don't have any orange flavor in the bag B. So now I'm going to write it down now. So I'm finding out the probability of the same flavors. So we have 3 of them having the same flavors out of the 12 outcomes. And because we are having 3 and 12, we can simplify it more by having a quarter. So now the third one is to do with, this says that different flavors. Now we are looking for all the possible outcomes which give us a different flavor. So we have got a lot of them which are giving us the different flavors. You can even do in 2 different ways. So one of the way of doing that is you count how many are the different flavors you're having, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that we are having a different flavors of 9. So I'm going to write down that we are finding out the probability of the different flavors. So to get the different flavors, when we counted them, it's 9 out of 12. And after simplification, you'll get 3 over 4. Or in other words, if you think that if we are having quarter of them is the same flavors and the remaining fraction would be 3/4, that would also represent for the different flavors. So either way, if you do it, that both the ways are correct. Now we have got our last example on the finding the probability using the sample space. And let's read it together. So we are having, my highlighter is ready to highlight the key information. This is that's an exam style question. So it's interesting to read and do the exam style questions always. This is that Lewis spins a 4-sided spinner and a 5-sided spinner. So we have got 2 spinner. One is a 4-sided, another is a 5-sided. And we can see that what are the numbers we are having on the spinners then. So this is the spinner numbers of the 4-sided. This is on the 5-sided. Lewis added the scores on the 4-sided of the spinner to the 5-sided spinner. So the relation between them is adding them together. And here they have shown over here as well. That's to add them together. She records all the possible outcomes, and the first part is to fill in the table. So to fill in the table, what they do is it's just they're adding the scores. So these are the 4 boxes. I'm going to, because I don't have enough space over there, I'm going to draw my 4 boxes here. Okay, so to draw the 4 boxes, if you do 7 plus 6 would be 13. And because I think I still don't have enough space, so I'm going to try to draw a big box now. So here is the boxes now. Now we see that we are having a number 7 and 6. When you add them together would be 13 here. Then you are having 7 and 8. So it would be 15. Then we are having 9 and 6 would be 15. And then we are having 9 and 8 would be 17. So we have got the part A to fill in the table with the possible scores. Now, the part B is write down all the ways in which the Lewis get a total score of 11. So I'm going to highlight it. We are looking for those only which are giving us a total score of 11. So one of the way is done for you. So one possible combination which they have done for you already is 2 and 9. Let's see that what else is giving us 2 and 9. So I'm changing the color. So here you go. This is another highlighter color I've taken. So let's see that which ones are giving us 11. This is giving 11. This is giving 11. This is giving 11. And this is giving 11. The first one is done for us already, which is 2 and 9. The next one is a combination with 4 and 7. So I'm going to write down 4 and 7 is the next combination. The third one is giving us, which is 6 and 11. 6 and 5. So the third one is given us as 6 and 5. And the fourth one is 8 and 3. Now we know that the possible outcomes could be these are the all possible outcomes we are having, and that gives us all of them are giving us a combination. The sum of them is 11. You can even check your answer by adding them together. 2 plus 9 is 11, 4 plus 7 is 11, 6 plus 5 is 11, and 8 plus 3 is 11 as well. So all of them are giving us a sum of 11. Now the next part is, which is the part C. This says that both spinners are fair. Find the probability that Lewis' total score is less than 6. So we are finding out all the scores which are less than 6. So we see that how many outcomes are actually giving us less than 6, and I'm going to highlight all of them. So now this is less than 6, this is less than 6, then we are having 5 which is less than 6. So we're having actually 3 outcomes which are less than 6. So we're going to write it down then. We are having 3 out of the total. So we know how many other total outcomes are, which is in the row we are having, so in the first spinner we are having 4 outcomes, in the next spinner we are having 5. So the total outcomes would be when you multiply them together, which would be 4 times 5, and then it gives 20. So the probability less than 6 would be 3 over 20, because we are only having 3 numbers in the list of all the possible outcomes which are less than 6. So here is all the examples on finding out the probability using the sample space diagram, and I hope you have find this video useful in understanding the topic. So thanks for watching the video.